Let's try this. So every ordered pair AB that satisfies the equation y equals 2 plus 3x over 5 plus x squared also satisfies the equation this for positive integers a, b, c, d, and e. Find the sum of a, b, c, d, and e. Okay, so what solves this? We see that this is a rational function with the higher power and the lower end. So I think this is gonna look, why don't we just put a number in just for a reference? It's gonna look like, wait a minute, I'm confused. Because one way we could solve this is expand this, isolate y, and then change A, B, C, D, and E to follow this. So, but that doesn't make sense here, does it? Oh, let's try it. We have 2xy squared minus 4axy plus a squared is equal to bd bd plus minus bey plus cdy minus cey squared. So the thing is here we both have y and y squared, so that kind of sucks. So can we even isolate y? Do we have to use the quadratic formula maybe? I think that might be the way. So in front of y squared we have 2x minus cey ce times y squared. Then we have plus be minus cd minus 4axy plus a squared minus bd is equal to 0. Okay, now we can isolate for y. We have y is equal to negative b. So we have 4ax plus cd minus be plus or minus the square root of b squared. So be minus cd minus 4ax squared minus 4 times I totally did this wrong. This is 4x squared. So this should just be 4. For x squared plus CE plus CE times A squared minus BD all over 2 times 4x squared plus CE. Okay, so we see this kind of works because on the bottom we have an x squared. On the top we have, this is just normal power x, this is to the power of 1, and then this is x squared. So this kind of works. So now we just need to expand and probably just figure this out. So it's the same thing there, plus or minus over 8x squared plus 2CE. This, okay, this is going to be hard. So what we have to do here, there has to be another way to do this. Maybe we just need to keep plugging in ordered pairs until we get something. So let's try 0, 0. We get 0's equal to... Oh wait, we don't even know if that satisfies. Let's put x equals 0. Then we get 2 over 5. So 0, comma 2 over 5. Put x equal 1. We get 1 and then 5 over 6. We put x equal 2. We get 2, comma 2 plus 6 is 8 over 9. So maybe let's plug that in. We put this first one in. We get a squared is equal to it'd be a good one, set y equals 0. 0 is equal to, the bottom can't be 0, but the top can be, it's going to be negative 2/3. So we get a squared is equal to e times d. That is an accomplishment. We did that. And that's a good amount of information. So now should I plug this in here, negative root BD? I don't want roots in here. Would be another good one. We can't really get another good one, I don't think. Other than 0 for x, where we get a squared is equal to I guess here you could use b times d. B times d is equal to b plus 2/5 c times d minus 2/5 e. So here we get bd is equal to bd plus 2/5 cd plus 2/5 be, or minus 2/5 be, and then we do minus 4/25 CE. So then cross these out. So we get 0 is equal to multiply by 25. We get 0 is equal to 10 CD minus 10 BE. 0 divided by 2 is equal to 5 CD minus 5 BE minus 2 CE. What's interesting here is that these two contain C, these two contain E, but these two don't contain B. I think that's because if we had not gotten rid of BD. But, so this gives us another relation, but it's much, much less clear. Oh, hey, look. A squared minus BD. A squared is equal to BD. This goes to 0, which means this goes to 0. Oh my gosh, that helped us so much. So now we don't need to square this, we just have plus or minus BE minus CD minus 4AX. Here we get 4AX plus CD minus BE. So this is just B plus or minus negative B. It can't be plus negative B because that would just cancel the 2 out, so it has to be minus. So then minusing the 2, we just get 2B, which is going to be 2B over 2A, so we can cancel these both out. So we have 4AX plus CD minus BE over 4x squared plus CE. Okay, so x squared needs to be just singular, so divide everything by 4. We get AX plus 1/4 CD minus 1/4 BE over x squared plus 1/4 CE. Okay, so we know A is equal to 5 or 3. A is equal to 3, which means A squared is equal to 9, which means BD is equal to 9. So this just goes to 3. Now we need this term down here to be 5. So 1/4 CE is equal to 5, which means CE is equal to 20. Do we know positive integers A, B, C, D, E? So here BD can be either 1, 9, 3, 3, or 9, 1. Here CE, there are a bunch of options. We don't know. And then we have this here. This needs to equal 2. So 2 is equal to 1/4 CD minus 1/4 BE. So 8 is equal to CD minus BE. All we know about these numbers is that CE is equal to 20. So we know the product of this and the product of this, which is kind of weird. We don't know we don't know this times this or this times this. So do we have to just try all ordered pairs? So here we have 1 and 20, 2 and 10, 4 and 5, 5 and 4, 10 and 2, and 20 and 1, which sucks. So we have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. What? 1, 2, 3, 4, 5, 6 times 1, 2, 3 is 18 options. And we just need to find their sum. Okay. So CD, let's start with this one, 120 for C and E. So 1 times 9, no, 1 times, yeah, this one won't work. Here, their difference needs to be 8. So 2 times 9 is 18, minus, oh, there we go, 2 times 9 minus 1 times 10. 9 and 1, 2 and 10. So 2 plus 9 plus 1 plus 10 plus 3 is our answer. This is 10, this is 13, this is 23, this is 25. Let me check. Wow, I surprisingly got that right with the correct numbers and everything. I just didn't do what they wanted me to do, but I still managed to get it through trial and error. So, wow, my inventive way with the quadratic formula really worked. I'm so surprised I got that, because I just managed to realize, hey, this is not that, so then that cancels that out. So there's no way I would have gotten that if I didn't find that. Cool, thank you guys for watching. I'll see you guys tomorrow. Bye.